stations. So let me just explain the question quickly to you, what the question says. I hope you had given this question already a try, and you might stuck somewhere. So we'll be looking into that. So the question says we have two stations, station P and station Q. So station P is located at the top and left boundaries, and station Q is located at bottom and right boundaries. So basically station P will be here and station Q will be here. And there are these towers. So cells are towers in this question. For example, this 5 is a tower, 4 is a tower, 5 is again a tower. So we have to find from how many towers the signal can reach to both station P and station Q. Okay, so for example, let's look into one example over here. So considering this tower with value 5, we have to check if the signal can be reached to station P and station Q both simultaneously. So here there is one condition or one rule mentioned, that the signal can be reached to the neighboring towers. So a signal can propagate from a tower to one of its neighboring towers in a 4 directions. So the signal can propagate to only 4 directions from source tower, and further it says only if neighboring tower has a signal strength less than or equal to that of current tower. So means it can propagate to the 4 neighboring towers, but the condition is that the value in the neighboring tower must be lesser than equals to uh, value that is present in current tower. So for example, if we consider this cell 5, so from 5 to this cell it can propagate as 3 is lesser than 5, and from 3 to 1 it can propagate as its uh, 1 is already lesser than 3, and station from 1 it's already can reach to station Q, as in question they have mentioned station Q covers right and bottom boundaries. Similarly station Q covers left and top boundaries. So similarly, uh, we'll check if it can reach to station P. So if, as you can see, it can reach station P like this. Now if we'll check for station, let's say this 4, it can reach to station P, but we'll check if it can reach to station Q or not. So from 4 to 7 it's not possible to avoid, so it will not reach to this station. Similarly, it will not reach this station as 5 is greater than 4. So station Q is not reachable from this tower. Okay, the solution approach for this question will be something like this. So, so in the brute force approach, we can try from every uh, cell if it can reach to station P and station Q. So in that case, we'll need to iterate on this matrix. So the complexity for that would be big of n square. So big of n square or big of n cross n. So it will be in order of 2. Right, so we'll reach to every cell and ask if it can reach to station P and station Q. So for that, again we'll need to, for every cell we'll need to propagate, uh, and we'll need to check if it can reach to station P and station Q both. So the minimum time complexity for that would be minimum of n comma m. So minimum of n comma m, so it goes to order of 3, and here the constraints are mentioned, like we can only have n comma m up to 10 power 3, and 10 power 3 and going order of 3 it goes to 1e9. So that many computations cannot be performed, so this will lead to TLE. Now this is very standard type of question in which we have to think in a reverse direction. So rather than going from every cell or every tower to every station, we will go from station to cell. So for example, uh, we'll see station P can reach to which cells. Similarly, station Q reach to which cell. So it is basically very easy multi-source BFS. So we'll start BFS for station Q with this cell, that is bottom and right boundaries, and similarly for station P we'll start the BFS in the top and left boundaries. So let me just explain you solution quickly, what I'm doing over here, so it will be more easy. So here is our signature that we need to complete. So here we are maintaining two visited arrays, in which for first visited array we are maintaining uh, for station P if station P can reach to that cell or not. Similarly, visited to maintain station Q reach to that cell or not, and we are just completing the BFS for this uh, two stations. So 0 means station P and 1 means station Q. Let's see what we are doing in a BFS. So this BFS is a very standard BFS, nothing extraordinary much over here. So here we have Q that will be having that source, and visited will be again um marking if we have reached that cell or not. So here option means just tell if we are doing BFS for station P or station Q. So if option is equals 0, then we are having we are on the station P, and we'll be pushing this two uh, this row and this column into our queue. Similarly, if in other condition we'll pushing this as it is for station Q. So let's see the flow for station P. So if option equals 0, then we are pushing just the uh, top row and leftmost column. So we are just pushing it into the queue and marking that as visited, as it is reachable from the station P. Uh, Now again dx and dy are these are again two standard arrays to just iterate on the directions, four directions. So -1 comma 0 will be left direction, then 0 comma 1 will be uh, bottom direction, this will be top direction, this will be again right direction. Now going ahead, here we are just getting the front row. Over here we are having current x and current y, uh, and again we are iterating to the all four neighbors. So new x comma new y is one of the neighbors in the four directions, and we are just checking if it is in the limits or not, and it's not already visited. And here there is one interesting thing. So in question, as if you have seen, they have mentioned uh, from every tower you can reach to every other neighboring tower if and only if the value in that other tower is lesser than equals to current tower. So here we are inversing that condition, because we are not going from cell to station, cell or tower to station. We are rather going from station to tower. So we will check uh, if for this cell, if neighboring cell has a value greater than this cell. So for example, from this cell with this cell or tower, we'll be checking uh, if we can reach to this other cells. So we are traveling in inverse direction, rather than traveling from tower to station we are traveling from station to tower. So that's why I have inverted the condition over here. So that explains the reason why I have written the uh, condition in that way. And here again we are just doing a standard DFS, pushing that cell and again iterating on the other neighbors. We are just returning the visited vector here, again iterating just on the cells, and we are checking if it's reachable from station P and station Q. If it is, we will increment the answer and will return the answer. So yeah, that's the solution. Let's just submit it, and I've checked it, it's passing already. So yeah, that's the solution guys. Thank you very much for watching.